Okay, we're going to talk about 2.4 applications of the trig function. So we'll need to, first of all, we're going to be using a calculator today. I want you to turn your calculator on, and when you start this, I want you to go to mode, and I want us to put it in degree mode. Okay, we're going to start in degree mode. We may switch back to radians, but I want you to always check, see which mode your calculator's in. We are going to focus this video on solving a right triangle. There'll be a couple other videos coming up. This will be video 2.4a. Solving a right triangle means that you're finding the missing lengths of its sides and the measurements of its angles. We will label right triangles so that side lowercase a is opposite of capital angle A, lowercase b is opposite angle capital B, and side C, the hypotenuse, is always opposite the right angle capital C. When solving a right triangle, we will use the sine, the cosine, and the tangent rather than their reciprocals. We have a triangle here. It says A is 62.7 degrees. And it says side A is 8.4. Solve the right triangle, rounding the length to 2 decimal places. Well, the first thing that you need to do is you need to look at your angles. You know that this is 90 degrees. So, first thing you need to do is you know that angle A plus angle B is 90 degrees. So, if you want to solve for B, you just take 90 and subtract angle A from that, and it's 27.3 degrees. Now, I'm going to record that here, 27.3 degrees. And I used a little bit different color. I'll talk about that in just a second. Now, we want to find the lengths of the sides. Okay, we want to find the lengths of the sides. I know that A is 8.4. If I want to find B, let's say I want to find B, I want to be sure that I know which angle perspective I'm looking from. So I'm going to put smiley face over here at A, and I'm going to be standing at A. If I'm standing at A, of course this is always my hypotenuse, then that makes this my opposite side and this my adjacent side. Now, I chose angle A to put my smiley face at because it's an angle value that they gave me. I'm the one that calculated the measure for angle B, and if I made some kind of mistake, I don't want it to follow me through the problem. Now, if I'm situated at angle A and I want to find side B, I'm using the opposite and the adjacent, and that tells me that I need the tangent function. The tangent of angle A is equal to the opposite over the adjacent. Well, the tangent of 62.7 degrees is equal to 8.4 over B. Now we have the variable we're looking for in the denominator, so we're going to have to multiply both sides by B. So I will have B times the tangent of 62.7 degrees equals 8.4. I'll need to divide by the tangent of 62.7 degrees. That'll give me my answer. Now, again, make sure you're in degree mode on your calculator. 8.4 divided by the tangent of 62.7, and that gives me, round to 2 decimal places, 4.34. Okay. Now I need to find, see what I'm going to do. I'm going to circle that. I calculated those 2 items, so I'm going to try not to use them in finding the other parts of my triangle. I need to find the length of C, lowercase c, the hypotenuse. And I want to use this because they gave me this, and I want to use this angle because they gave me that. So that's the opposite in the hypotenuse. So I'm going to need the sine of angle A, and it's going to be the opposite over the hypotenuse. So the sine of 62.7 degrees is equal to 8.4 over the hypotenuse. hypotenuse is lowercase c. Again, I'm looking for c and it's in the denominator, so I'm going to have to multiply both sides by c. So c times the parentheses sine of 62.7 degrees equals 8.4. So I'm going to divide both sides by the sine of 62.7 degrees. So that gives me 8.4 divided by the sine of 62.7, 9.45 for C. Any questions on that? Okay, moving right along. From a point on level ground 80 feet from the base of the Eiffel Tower, the angle of elevation, that's this angle right here, is 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. Well, we're in feet here, so I don't have to do any conversions there. This is my perspective. This is where I'm looking from. When I'm looking from here, this is my opposite and this is my adjacent. So I know that I am using the tangent function. The tangent of 85.4 degrees is equal to the opposite over the adjacent. I need to multiply both sides by 80. So 80 times the tangent of 54 degrees, 80 times the tangent of 85.4 degrees is 994 feet. Nearest foot, 994. A guy wire is 13.8 yards long. It's attached from the ground to a pole 6.7 yards above the ground. So we've got our drawing here. Find the angle to the nearest tenth of a degree that the wire makes with the ground. So this is the angle I'm looking for. So that's where I'm going to put my perspective. I'm looking from here. If I'm looking from here, this is my opposite and this is my hypotenuse. So that tells me that I need to use the sine. The sine of A is equal to the opposite over the hypotenuse. So it's equal to 67 over 13.8. So I know the ratio. It's the angle I'm looking for. So we need to go back and we need to use sine inverse. So you press second sine and you enter your ratio. And I come up with 29.04. And they want me to round it to the nearest tenth of a degree, so the 4 does not cause the 0 to go up. So my answer here is 29.0 degrees.